In case you are wondering, this is not a food channel, but we are talking about how amplifiers work. And this is about the power supplies and pie filters. And pie filters are not pies like a cherry pie, but let's just show you how a pie filter looks like. So in any amplifier schematics, you need a stable DC supply for your vacuum tubes, or even if you use a transistor or transistors, you still need a stable plus and minus DC supply. So so here's our supply, and it supplies a positive and a negative voltage. And let's say if you use a transistor amp, then maybe this is called a rail voltage. Maybe you have like a 35 volts positive rail, and then you need it to be exactly 35 volts, and you don't want any kind of noise, any kind of choppiness riding on it. And if you use a tube amplifier, then it's a similar situation, but you have to multiply the voltage many times. So in tube amps, instead of the lowly 35 volts or maybe 12 volts, 14 volts, you have voltages like 200 volts, 500, or maybe even a kilovolt, or even higher, several kilovolts, several thousand volts. And the job of the power supply is to provide a stable, smooth DC voltage. And that's quite a bit of a feat, because what we have in our walls on the AC socket, that's not a DC but an AC voltage. So there the voltage fluctuates between extremes, and from this we need to create this. And to do that, that's very hard. So every power supply, when it does the conversion, you pretty much get a tiny ripples in it, or maybe even bigger ripples in it. And the least amount of ripple you have, the better your power supply is. And how you can achieve that is that first you have your rectifiers that create the choppy DC voltage. So it's not alternating current, but it's DC. However, it's very rough, and we need to smooth it out. And we can smooth it out by these pie filters. So instead of a cherry pie or a chocolate pie, we have a combination of either a resistor and a capacitor. So the capacitor goes between the negative and the positive terminals, and the resistor or a choke, it can be a choke here, they go in series with your power supply rail. So when you have one such element, a resistor or choke plus a capacitor, that is called a pie filter. And one is usually not enough to create a clean enough voltage, and then we can add one more. And then we have one pi section, a second pi section, and maybe we can add a third, and usually we need at least 3 to create a nice and stable DC voltage for low signal levels. And also the cheapest way to create a stable voltage is also to throw in a transistor into the mix, and use a transistor to regulate the voltage. So in that case, we use the transistor device. We can insert it here, and it will act as a regulator to regulate, and then here it attaches through a resistor to the ground, and then it looks at the voltage between the input and the output, and tries to correct whatever error there is between the two. So instead of requiring many of these pi filters, your transistor can do the smoothing in a single step. However, it is an active job, an active duty, and when you have an active component, you also introduce errors made by that device. Hence, when you want to do a pure design, then you want to just make and use of these passive filters. But the problem with these passive filters is that you see there's a resistor, so this is burning up voltage. So your input voltage has to be much higher to provide a nice and clean rail voltage, or B plus for tube amps. And however, if you don't want to drop that much voltage, then you can add a choke instead of the resistor here, and that's the proper way of doing a pi filter. However, if you make the comparison between them, a resistor is like a 10-cent or maybe a 50-cent piece, and it's really tiny, doesn't occupy any space. And the choke, depending on the application, it can be like up to like a pound weight, like a big piece of iron, as big as your output transformer or mains transformer, and can cost like even $100 or more. So it makes a tremendous difference in production costs, whether you use a 10-cent piece or a $100 piece. And that's why some tube amps cost so much, because you just have to multiply the cost by 1,000 with each pi filter you use. However, when you use a choke, the advantage of a choke is that they have a huge resistance for an alternating signal, but very low resistance for a DC signal. So it means that when you have your vacuum tube here, it can instantly access a large amount of current, a large amount of voltage. And if you have resistors, then when your tube or transistor would need more juice, more current or more voltage, then the supply cannot supply it because the resistance slowed it down. So that's why there's so much attention and so much talk about power supply impedance, which is another word of saying resistance, because impedance always applies resistance at a certain frequency. So this is the basics of power supplies, and thank you for tuning in. And now it's time for a pie, and please like and subscribe. Thank you. Bye bye.